All right, this lesson is for calculus. It comes from 7.2. It is on volume, and this video will specifically be volume rotating, okay? So here is my formula for volume rotating. We have pi times the integral, and then we have two sections to this, okay? Looking at my image, these two functions are going to create an enclosed space, okay? That enclosed space will intersect at 2 points, right here at A, and right here B, okay? So just like an area, we're going to have to set them equal to each other to solve for that A and B. Now, C is where I want you to rotate these two functions around. C will always be a number, okay? And that will go in this spot. If C is the x-axis, then my value for C is 0, and this portion is going to end up getting eliminated from my equation. Okay? Now, those two r's represent my two functions. Capital R, I labeled this one, is the function that is furthest from what I'm rotating around, from C. And lowercase r is the function that is closest. If I eliminate one of those functions, then I'm only working with one function, so this entire side gets eliminated from the equation. Okay? So again, don't be afraid if there's instances where C is 0 and then that's not in the question or in the formula, or there's not a second function, okay? Let's take a look at this first equation. Revolve the absolute value of sine of x, which is going to exist from 0 to pi, around x-axis, okay? Did I say absolute value of x? Yes, I did. I meant square root of x. I apologize. So I know that from 0 to pi, it is this first portion of sine. So they're really nice to us here. They already gave us my A and my B. Okay? Now, remember, square rooting just makes the y value smaller. So instead of this going up to 1, this is going to go up to some smaller number in certain points. Okay? So it won't affect my drawing right now. My job is to find what that enclosed space, this enclosed space right here, what volume it's going to make when I start rotating it around the x-axis. Okay? So it'll kind of start rotating and it's going to make like an egg shape. Can we understand that visual? So the next thing that I've understood here is that if I'm rotating around the x-axis, who is my C? Good. And specifically, I'm going to write that it's y equals 0. That's going to help us in the future when we start changing things. So because this is rotating around, if you're in my class and visually watching me, we talked about how when we rotate over and under, it's like what white girls do with their hands when they dance. Okay, so right now that's going to seem simple, but when we start seeing it go the other way, going side to side rotation, it'll get a little more complicated. So I know that C is 0. How many functions do I have when I put my pencil on C going out? I only have one function. So don't worry about capital or lowercase, okay? When I come back to my formula, one whole side is going to get canceled out. And my C is going to get canceled out. So this equation is going to be as simple as the integral of just r squared, okay? So I will go through the motions. Don't feel like you have to do this like on your homework quiz and test. But you would be writing pi times the integral from 0 to pi. Again, I'm going to write this really detailed. You do not have to do this. C is 0 minus my function is square root of sine x. All of this gets squared. And then because I don't have a second function, I don't have that second part. Okay? So this 0 eliminates. If I square a negative, it becomes positive, so that eliminates. And then square a square root of sine, what am I left with? Just sine. So I'm left with pi times the integral from 0 to pi of sine of x dx. Okay, so again, 0 becomes irrelevant. When I square a negative, it becomes positive. And when I square a square root, it eliminates. Okay? So next step, what is the antiderivative of sine of x? There you go. Say with confidence, negative cosine of x. Okay? And this is going to go from 0 to pi. The biggest mistake I see in these questions is that people forget to bring down that pi. Very, very common. Okay? So now I have pi times negative cosine at pi minus negative cosine at 0. Okay? Am I done there? I just finished my f of b minus f of a. No, why not? What do I have to finish? The trig, okay? So what is cosine of pi? Negative 1. So I have negative in front of the cosine, and then cosine of pi is negative 1 minus negative, what is cosine of 0? Right. Okay, so technically you could stop right there. But if we wanted to, if this was like, let's say, a multiple choice on a AP test, you would be expected to finish this, which isn't too bad. I have pi times, this becomes a positive 1, and this becomes a plus 1. So I end up with 2 pi. So this is where I stop for a multiple choice. And this is where I can stop for an FRQ, for a free response. Okay? So let's look at our next example. Revolve both of these functions around the x-axis. So the moment I see the x-axis, first thing I know, what do I know, guys? If I'm revolving around, right? C is y equals 0. Beautiful. Okay? Now, I'm going to start sketching. Okay? So, square root of x is it shoots out like this, like a teapot. Okay? And then x squared on the right side goes upward like this, and on the left side would continue on, but being that it doesn't create a bounded area, we really don't care about that left side of that parabola. Okay? So my next step is to figure out what A and B are. Visually, if you know your graphs, A should be easy. What do you guys think A is? 0, because my parabola and my my radical didn't shift. Okay? But let's set them equal to each other anyways. So this is going to make an image in here, a bounded area, and they want us to rotate around the x-axis. So I say square root of x equals x squared. What should I do next? Square both sides. Okay, so now I have x equals an exponent to an exponent. We multiply, so this is x to the 4th. Okay, now I can move them to both sides, or I can divide by x. Okay, I'm going to stick to the same method we were doing last class, so you guys have that one method in your head. So if I subtract the x over, I have x to the 4th minus x equals 0. Factor out an x. And now we have x equals 0. Here's that 0 that we were talking about. And then x cubed, if I move over the 1, equals 1. What is the cube root of 1? 1. Okay. So I know that my 0 goes right here, and then my b is 1. Okay. Now, I need to start setting up my integral. Okay. I'm going to say pi times the integral from 0 to 1. If c is down here, looking at the bounded area, which function is furthest from 0? The square root. So if I put my pencil here and I start drawing upward, the closest, the first thing I hit, First thing I hit is this parabola. So this is my little r. Okay, so that means this guy right here is my little r. And then as I keep going, the further one is the square root. That is my capital R. And in a moment, I'll show you how to do that without needing the graph, okay? So I'm going to have C minus, which is 0, minus my capital R, which is the square root, squared, okay? Minus C, which is 0. Once you get good at this, you can skip writing that 0, okay? Minus my closer function, which is x squared. And then the formula tells me to square, and I write my dx. Okay? So the 0 and the negative will cancel. The negative because I'm squaring. If I square a square root of x, what am I left with? Just an x. So I have x minus this 0 and this negative will cancel. Okay? What is x squared squared? X to the 4th. All right, and here's where the easy part comes in. It's just the calculus. The hardest part was figuring out my setup. Okay? So, bring down your pi. Antiderivative of x is? Good. And of x to the 4th? Beautiful. And now complete your f of b minus f of a. We know when I plug in 0 into all of that, it'll just give me 0. So this is an appropriate answer for a free response. Now, if this was a multiple choice question, I would have to finish. So this would give me, this one isn't actually too bad at all. 1 squared is 1. 1 times a half is just a half. Same thing with 1 to the 5th. Okay. So this would just give me, get common denominator. Three pi over 10. And again, this is only necessary if this is a multiple choice question. Okay? Now, if you're not a big fan of graphing, okay, and you don't feel confident always graphing these, I'm going to give you another option. I left this space here on purpose. So we'll call this who is capital R and who is lowercase r. Okay? So I want to pick a number to test in between 0 and 1. What's an easy number between 0 and 1? 0.5, right? So I'm going to check what 0.5 plugged into each of the functions give me. So square root of 0.5 and 0.5 squared. So the reason why I'm not a fan of only doing it mathematically is because you would need your calculator for this. And calculators are not always allowed, like on the AP test. So square root of 0.5. Is that going to give me a bigger, who's going to give me a bigger or smaller number? Be careful, because if I was squaring and square rooting a whole number, it would become larger. But when you're squaring and square rooting decimals, it works opposite, right? It's just going to give me a bigger decimal, okay? So this one's going to give me 0.25. And then this one is going to give me something like 0.7, okay? So now you're asking yourself, it's not like when we talked about area, we talked about top minus bottom, so we talked about bigger minus smaller. Now we are talking about who is closer and further to C. If C is 0, who is closer to 0? Right, because this is closer to my C. Right? So this would make this one lowercase r. Okay? And then further from C would be my capital R. And we know that 0.7 is further from 0 than 0.25 is. Okay? So you have two options here. You can see this visually with a graph, if you feel confident with graphing, or you can see it with testing numbers in between A and B. Okay? If you're asking my advice, I'd encourage you to strive for both, because sometimes you're going to feel, oh man, doing squared and square roots of decimals is hard. Sometimes you're going to feel like the graphing is harder. It'll depend on the question. Okay? All right, let's look at this third example. Revolve f of x and g of x around the line y equals 1. Okay? So, g of x equals 1. What does that look like? Sorry, hold on. I'm going to fix my image here. All right, I fixed my image. So, g of x equals 1 is a line at y equals 1. Right? So, if this is 1, then it's just a line that shoots out. Okay? Now, 2 minus x squared. What is that a function of? Parabola, facing down because of the negative. And what does that positive 2 mean? It went up 2. So up here at 2, we have some parabola that goes facing downward. Okay? So can you see that the bounded region is right in here? Okay? And then it says to revolve around y equals 1. That y equals 1 is he's my C. Okay? Now, let's start setting up our equation. Okay? We have pi times the integral. I'm going to have to find out where they intersect. Okay? In a moment. Now, I need to say C minus. So if C is 1 and I have two functions, this is one of those things so easy that you might overthink it. Who out of those two functions is closer to 1? G of x. It's literally on top of it. Does that make sense? So this guy right here is my little r. And then furthest from 1 is f of x. Okay? So C, I put a C. Let's go putting in the number already. C is 1, so 1 minus my capital R. If your function has more than one term, you have to put parentheses here. Okay? Because this negative is going to apply to both terms. Be very careful there, okay? Minus C, which is 1, minus, who's my closer function? 1. Whenever your C and one of your functions is the same exact thing, that portion is going to end up canceling out. Okay? So this whole portion is going to end up canceling out. Now let's take a moment and find where they intersect. If I want to know where they intersect, I set them equal to each other. Move everything to one side. So I'm going to move the x squared to the right. And then I have 1 minus 2. It should give me minus 1. Okay. X squared equals 1. What does the square root of 1 give me? Not just 1. Nice. Plus or minus 1. So you can see that these two spots here are -1 and +1. Okay? So let's keep on going. Here, again, the calculus is the easy part. Here is one of my biggest mistakes that I see every year. You have to distribute this negative to both terms before you can square it. Okay? So I have pi times the integral from -1 to 1 of 1 minus 2 plus x squared squared. This cancels out, and I have a dx. Okay? I'm going to continue cleaning. 1 minus 2 gives me a -1. So I'm going to say x squared minus 1 squared. Okay? I'm going to have to do some foiling here. Remember that this squared does not distribute to each term. It means that this entire binomial is going to get multiplied by itself. So what I'm really working with is x squared minus 1 times x squared minus 1. Foil that. Whoops. I made a mistake. There we go. And then these two combine, and I'll have pi times the integral from -1 to 1 of x to the 4th minus 2x squared plus 1 dx. Okay, so now comes the easy part, the calculus. Bring down my pi, antiderivative of x to the 4th. Good, antiderivative of 2x squared. And antiderivative of 1. And this goes from -1 to 1. Okay? Now this will have a little bit of a lengthy answer. And here you are done for an FRQ. Okay? Now something that I like to enforce, and not so much that you have to do it this way, but just to expose you to it. In my AP classes, if this was multiple choice and I had to do all this by hand, it might take me a little while. Okay? Look at the image. Do you agree that x squared shifted up to is still an even function, meaning the right and the left side give you the same quantity? Okay? So that means that this space right here is going to give me this same exact amount on this side. If you catch that you are working with an even function that is still split perfectly, you can solve this from 0 to 1 and double it. Okay? So I'm going to put or, double my answer. And if it's from 0 to 1, then I really only need this first portion. Because then it's just minus 0. Okay? Not necessary, but it is an option. Okay?